Hydrogen fuel cell, technology and applications. Abstract: A hydrogen fuel cell is well known as an electrochemical power generator which generates energy by combining hydrogen and oxygen. A fuel cell as a systematic conversion technology and hydrogen as an conveyor of clean energy have promising to contribute to directing an energy challenges currently being faced by almost all countries in the world. They will have an important role to play in a number of energy end-use sectors. To overcome the problems on energy sustainability and pollution associated with traditional fuel technologies, these HFCs are rapidly becoming an alternative of green energy technology. Pollutants from traditional and ancient fuels have a negative impact on the eco-friendly scientific environment. And hydrogen is one of the best energy sources to employ over other renewable energy sources since it has the power to produce massive amounts of clean energy. The hydrogen fuel cell, HFC, is proving to be a very promising future fuel in terms of lowering greenhouse gas emissions and reducing pollutants in the environment. In this work, a quick overview of hydrogen fuel cells is provided. Keywords: fuel cell, hydrogen, power generator, clean energy, sustainability, etc. Introduction: The innovative technology of fuel cell is established and developed in many countries in the world nowadays. Fuel cell systems have been renowned for their various advantages like high performance, efficient, high durability and eco-friendly with compared to other traditional power sources. As for that, many countries around the globe are trying to substitute ordinary power sources with fuel cells from time to time as this technology is rapidly evolving all around the globe. A fuel cell can be described as an electrochemical cell in which the chemical energy is transformed directly and effectively into electrical energy of conventional fuels. 1. And the most abundant and clean energy chemical element hydrogen, which accounting 75% of normal matter by mass and 90% over by the number of atoms. In a fuel cell system, when hydrogen is oxidized electrochemically, it generates pure water without emission of carbon dioxide. Hydrogen has many expanding application in various industrial fields such as power generation and equipment manufacturing for its clean and efficient advantages too. And because of rapid development, it has become obvious that many leading countries involves hydrogen fuel cell developments in their strategies to promote fuel cell industries. Thus, in this review we focus on fuel cell, its principle, types, and applications. Hydrogen energy. Hydrogen is practical of the effective elective powers for replacing the long-term fossil fuel. Hydrogen is intrinsically 6,1A lightweight iota found in plenitude on soil within the shape of 6,1A chemical compound, like water, for illustration. It has monstrous vitality substance compared to ordinary fossil powers. On the other hand, the bond vitality required to break 6,1A reversible hydrocarbon bond is comparatively less, and thus, comparatively less vitality is required to get hydrogen from its chemical compounds. Indeed, routine fossil fuels are complex compounds of hydrocarbons wherein hydrogen is considered to be the essential fueling source. It is the cleanest fuel ever found and can be gotten from water dissociation utilizing power. Owing to its properties, hydrogen is considered as 6,1A practical elective fuel competent of nourishing the fuel cells on board electric vehicles with no outflows. This would not as it were illuminate the issue of GHG outflows from vehicles but to resolve the issue of persistently draining oil saves. Other than, hydrogen fuel cells in combination with electric engines are 2-3 times more proficient than gasoline-powered inner combustion motors. In any case, its capacity in a proficient and secure way is however to meet the benchmark. So, hydrogen is unquestionably long-term fuel. For assembly the vitality needs of mankind, being 6,1A green source of vitality with mu GHG outflows and low carbon impression compared to the ordinary vitality sources. 17. Principles of fuel cell. A fuel cell is an energy conversion device that directly converts chemical energy of fuels in electrical energy with high efficiency and low impact on environment. 3. There are various types of fuel cell systems, but the function of all systems is same. The fuel cell system mainly consists of 3 parts: are an anode, cathode, and an electrolyte pillar. And according to the electrolyte material the fuel cells are classified 4. The simple arrangement of fuel cell system and the chemical reactions involved in an anode, cathode, and an electrolyte membrane in electricity production are given below 4.5. Fig. 2, Fuel cell operation diagram. The working of fuel cells involves the passing of hydrogen and oxygen into a concentrated solution via electrode. Hydrogen or fuel is introduced into the anode side of the fuel cell, while oxygen or air is introduced into the cathode side. As the gas tries to pass through the electrolyte membrane on the anode side of the cell, electrons are separated. The electrolyte membrane acts as a filter, separating electrons from hydrogen ions and allowing only the latter to flow through. The hydrogen ions that traveled through the membrane interact with oxygen atoms from the air supply in the cathode compartment to form H2O as a byproduct, as well as heat. The details are shown in the Fig. 1.14.6. Components of fuel cell systems. The fuel cell has 4 components. Anode. The fuel cell's negative post serves a variety of purposes. It transports the liberated electrons from hydrogen molecules to an external circuit. It is edged with channels that evenly distribute hydrogen gas throughout the catalyst's surface. 2. Cathode. The positive post of the fuel cell is carved with channels that transfer oxygen to the catalyst's surface. It also transports electrons from the external circuit back to the catalyst, where they can mix with hydrogen ions and oxygen to generate water. 3. Electrolyte. The proton exchange membrane is a membrane that allows protons to pass through. Only positively charged ions pass through this highly prepared material, which resembles typical kitchen plastic wrap. Electrons are blocked by the membrane. 4. Catalyst. A unique substance that makes it easier for oxygen and hydrogen to react. It's often made of platinum nanoparticles that have been very lightly coated on carbon paper or fabric. The catalyst is rough and porous so that the platinum surface area is exposed to the hydrogen or oxygen to the greatest extent possible. PEM is exposed to the platinum-coated side of the catalyst. 7. Fig. 3, Construction of fuel cell. Types of fuel cell systems. The type of membrane utilized in fuel cell devices is categorized. Fuel cell abbreviation membrane. Solid oxide fuel cells SOFC yttria stabilized zirconia. Direct methanol fuel cell Dmfc solid polymer electrolyte, NFN. Phosphoric acid fuel cell Pafc phosphoric acid, H3PO4. Polymer electrolyte fuel cell or proton exchange membrane Pempt solid polymer electrolyte, NFN. Alkaline fuel cell AFC aqueous solution potassium hydroxide, KOH. Table 1, Types of fuel cell systems. The Table 1 shows the common fuel cell systems with their membrane used for. Solid oxide fuel cell, SOFC. As fuel cells are characterized by their electrolyte material, the SOFC has a solid oxide or ceramic electrolyte 8. Negative oxygen ions are carried from the cathode to the anode by the electrolyte. Electrochemical oxidation of hydrogen, carbon monoxide, or other organic intermediates of oxygen ions happens on the anode side. SOFCs offer a number of benefits, including high combined heat and power efficiency, long-term stability, fuel flexibility, low emissions, and a low cost. And the largest disadvantage is the high operating temperature, which results in longer startup times and mechanical and chemical compatibility issues. 9. 2. Direct methanol fuel cell, DMFC. In a DMFC system, methanol can be used directly as a fuel in the FC. Methanol is a type of organic fuel that is made from coal or agricultural waste. The cathode and anode of DMFCs are both platinum and platinum-adopted catalysts. Trifluoromethane sulfonic acid was employed as the electrolyte solution. DMFC is a type of non-fuel flexible fuel cell that operates at low temperatures. Initially, these fuel cells were used in small portable electronic devices like laptops and cell phones. 10. 3. Phosphoric acid fuel cell, PAFC. A liquid phosphoric acid electrolyte is used in this type of fuel cell. Phosphoric acid, H3PO4, is a viscous liquid contained in the Fc in a porous silicon carbide matrix by capillarity. PAFCs are medium temperature fuel cells that conduct hydrogen ions rather than oxidizing ions, hence they are not as fuel flexible as high temperature fuel cells. While PAFCs are predominantly used for stationary power, they have also been implemented in some large-scale vehicles, such as public buses. 11. For polymer electrolyte fuel cell, Pempt, the solid polymer membrane is used as an electrolyte in this form of fuel cell, which is the most popular. The membrane is constructed of perfluorosulfonic acid in this case. This membrane allows protons to pass through but prevents electrons from passing through. This fuel cell has a low temperature range and operates at roughly 80 degrees Celsius. These cells are now mostly employed in the automotive industry. The advantage of these types of fuel cells is that they are very efficient and power density in the automotive engine size 4. 12. Fig.4, Basic structure of fuel cell based electric vehicle 4. 13. V. Alkaline fuel cell, AFC to conduct ions between electrodes. AFCs employ an aqueous solution of potassium hydroxide, KOH, as the electrolyte. The ion conduction process differs from PEMFCs because the electrolyte is alkaline. The hydroxide ion, O, carried by the alkaline electrolyte has an impact on various other features of the FC. A redox reaction between hydrogen and oxygen generates power in the fuel cell. Hydrogen is oxidized at the anode in accordance with the reaction, oxidation, H2 plus 2O. 2H2O plus 2E, 4. Water is produced, and electrons are released. The electrons go through an external circuit before returning to the cathode, lowering the amount of oxygen in the process. Reduction, O2 plus 4E plus 2H2O. 4O, 5. Ions of hydroxide are produced. In order to produce 2 water molecules, the net reaction uses 1 oxygen molecule and 2 hydrogen molecules. This process produces electricity and heat as byproducts. 4. 14. Table 2, Detail classification of fuel cell. 15. Applications of fuel cell systems. Fuel cells are gaining popularity as a result of their efficiency. The process is pretty straightforward. The fact that it has a low emission device and is silent attests to the fact that it produces a space that may be used in today's period. It demonstrates that this technology has so many suitable qualities that it outperforms current combustion engines, pistons, and turbine technologies. Fuel cells have properties that allow them to be employed not just on a small scale, but also on a huge scale. Fuel cell technology has made such an impact on everything from portable power systems to vehicles, electronic equipment, and big applications. The key areas applications are presented in the table. Table 3, Application of fuel cell technology. 16. Conclusion: over the last 15 years, hydrogen and fuel cell technology has improved significantly. At a worldwide level, this area continues to encounter enormous technological, commercial, and infrastructure-related hurdles that must be overcome before fuel cells can achieve their full potential. The information on fuel cells, including their detailed construction and operation, varieties of fuel cells, and their applications, is clearly explained in this article. In the future days, we may expect to see more fuel cell-based transportation, power plants, and electricity generators.